This is Algebra 2, Lesson 51, and in this lesson we're going to be covering imaginary numbers, products of square root theorem, Euler's notation, and complex numbers. Alright, the square of positive 2 and negative 2 are both 4. So we see that if we say positive 2 times positive 2, we get 4. The square of negative 2 and negative 2, so negative 2 times negative 2, is also 4. That is called the principal or positive root of 4 is 2. So principal root or positive root is going to be positive. 4 is how the negative square root of 4 is how we would designate the negative square root of 4. So that would be negative 2. You guys remember that. We've been doing that. So we put the negative outside, and then we say square root of 4 equals 2, and then we put the negative on. All right. If the square root of a number is multiplied by itself, the result is the number, and we've already done this. So let's say that you've got the square root of 3 times the square root of 3, you're going to get 3. The square root of 0.046 times the square root of 0.046 is 0.046. It follows then, if we did the square root of 4, negative 4 times the square root of negative 4, the answer would be negative 4. But we can't say negative 2 times negative 2 and get negative 4. Right? We would get positive 4. So the square root of negative 4 is actually an imaginary number. So square root of negative 4 times the square root of negative 4 would just be negative 4. But we can't find that on a number line. So that's what's called a imaginary number. It would just be negative 4. So that's what's called an imaginary number. All right, so when we're writing these, there's a certain way that we need to write these equations. So first, the square root of 3 times the square root of 5, square root of 15. We've already done that. Square root of negative 3 times square root of negative 5. 3 times 5 is 15. We're going to put the negative inside the square root box. If we have two negatives, negative times a negative, inside's positive, but the negative goes outside the square root box. So this is just a rule. If both roots are negative, the negative sign goes outside the radical. The radical is the square root box. All right. Next part. So for these, I've got square root of 3 times square root of 2. 3 times 2 is 6. It would be square root of 6. This one, the negative is inside one of those, so we're going to say 3 times 2 would be 6, so it would be square root of negative 6. This one, negative times the negative, we're going to put the negative on the outside. 3 times 2 is 6. Okay? So just a rule that you have to remember. If only one of them is negative, the negative sign is going to go inside. If both of them are negative, then you put the negative sign outside. All right, Euler's notation. So this is where we get the concept of an imaginary number. All right, so I, lowercase I, is equal to the square root of negative 1. And we know we can't find the square root of negative 1 because negative 1 times negative 1 equals positive 1, right? Positive 1 times positive 1 equals positive 1. But if we said the square root of negative 1 times the square root of negative 1, we're going to get negative 1. So it exists. It's just not something that we can find on a number line. All right, so when we simplify numbers using I, this one we're going to say the square root of 13 times negative 1, and the square root of negative 1 is I, so this would be square root of 13 times I, and the I is not under the square root sign. All right, so this one we would say square root of 4 times negative 1, and we know the square root of 4 is 2, and the square root of negative 1 is I. so that would be 2i. All right, for this one, we would say 3 times 2 is 6, so that would be the square root of negative 6, which would be the square root of 6 times the square root of negative 1, which would be the square root of 6i. All right, let's try another one. These seem complicated, but they're really pretty easy. A complex number is a number that has a real part and an imaginary part. To write in standard form, we're going to write the real part first. So this is a complex number. Here's our real part, and then 5i is our imaginary part. So we're going to write 4 plus 5i. Imaginary part goes last, real part goes first. 2 plus 9i. There's our imaginary, there's our real part. Easy peasy. So you're going to always write your real part first, then your imaginary part. All right, so when we add, we can only add like terms. So we can put our i's together, and we can put our regular terms together. Okay, so 4 and negative 2, 4 minus 2 would be 2. All right, and then we've got 6i plus 3i would equal 9i. And we wrote our real part first and then our imaginary part. All right, this one asks us to add some more stuff with some parentheses. So I'm just going to write all these out. So I've got 4 minus 3i. And then it's asking you to distribute, so this would be 6 minus 4i. Now when I distribute this negative sign out here, that's going to make that be negative 2. And then I distribute it here, negative times a negative makes a positive, so plus 5i. So just be careful with these parentheses. All right, now I'm going to have to add my real part first, so 4 and 6 and 2. So 4 plus 6 would be 10, minus 2 would be 8. Okay, so I've used up all these. Now I'm going to add my imaginary part. So I've got minus 3, minus 4, plus 5. 3 and 4 is 7. That would be negative 7. Plus 5 will be negative 2i. All right, that part is pretty easy. All right, simplify. Okay, so for ones like this, we know that I equals negative 1. So we have 2 times the square root of, here, let me do it a different way. All right, so we'll write it out. So I is going to be the square root of negative 1 times the square root of negative 1. And we already said that that would equal negative 1. Okay, so if we have I times I times I equals negative 1. Okay, so what we're going to do is we're going to group our i's. So we have 2 times I, so that'll be negative 1, minus 3 times, we have 2 of them, and then we got 1 left. See, there's 3 right there, so I put 2 in parentheses, plus 2i, minus 4, minus, all right, so the square root of negative 4 would be 4 times negative 1, and the square root of negative 1 would be I, so let's see, so square root of negative 4, that's going to equal square root of 4 times negative 1. Square root of 4 is 2. Square root of negative 1 is I, so that'd be 2i. So we'll replace that with 2i. Okay, so this, I solved it over here to make it be 2i right there. All right, now everywhere we have 2 i's together, I times I, we're going to change that to negative 1. Okay, so this would turn into negative 1. So 2 times negative 1 minus 3, that turns into negative 1. We've got an I left. Plus 2I minus 4 minus 2I. Okay, 2 times negative 1 would be negative 2. Negative 3 times negative 1 would be positive 3I plus 2I minus 4 minus 2I. Okay, now I need to put my real parts together first. I've got negative 2, negative 4. That would be negative 6. And then I'm going to put my imaginary parts together. Got 3I, 2I, 2I. So 3 plus 2 will be 5. 5 minus 2 will be 3. So plus 3I. And that's the answer. So when you have two i's together, that makes negative 1. Okay? All right. So this one is just about the same thing that we just did. So I to the third, that's going to be the same as 1, 2, 3 i's, right? And we group two of them. So we're going to say I times I, and then leave that one out. These two are going to make negative 1 I. Okay? So out of the third is negative 1 I, or just negative I. All right, so we're going to write it out like that. So we're going to say 3, and then we're going to group these two and leave 1. There's another 3. This is I squared, so we're going to group those two. Plus 7I plus 4 plus 2. This is I to the fifth, so we're going to have 1, 2, and then we're going to have 2 more grouped together, and then we're going to have 1 left over. So 1, 2, 3, 4, 5 of them total. All right, now every time we see two i's together, we're going to replace that with negative 1. So 3 right there will be times negative 1 times I plus another 3, and these two would make a negative 1 plus 7I plus 4 plus 2, and then these two together are going to make negative 1, and these two together are going to make negative 1, and then we have I. All right, now we're going to multiply those out. So 3 times negative 1 would be negative 3I. Positive 3, negative 1 would make negative 3 plus 7I plus 4. All right, so right here we have 2 times negative 1 times negative 1. Negative 1 times negative 1 is going to make positive 1. Positive 1 times 2 would just be 2. So plus 2I. All right, now I'm going to add my real part first. So I've got negative 3, positive 4, which is going to be 1. I'm missing something. Hang on. Negative 3. Oh, I wrote my problem a little bit differently than in the book. So in the book, this is a 2 up here. Okay, but we won't worry about that. We're just going to do it this way. All right, so negative 3, positive 4 is going to be 1. And then that U stays up. Now I've got all my i's left. I've got negative 3I, positive 7I, positive 2I. So 7, 8, 9 minus 3 would be 6. So positive 6I. And that's the answer for that one. A little different than in the example in the book. This is a 2 because this was a 2 up here instead of a 3. All right, let's try another one. Oh, time for the practice problems. All right, so pause the video, do the practice problems, and then I'll work them for you. Okay, hopefully you guys pause the video to do the practice problems, and let's see if you got them right. All right, so we're going to start with changing this notation here. So 2, and we're going to group those i's together. minus 7, and we're going to group these two, plus 2i minus 4 minus, okay, so the square root of negative 3 would be equal to the square root of 3 times 1, negative 1. So that would be the same as the square root of 3i, okay? So it's minus square root of 3i. Okay, so these are going to cancel, and that's going to make negative 1, and those are going to turn into negative 1. So then we're going to multiply those. We're going to say 2 times negative 1 would be negative 2. Okay, there's that whole part. Negative 7 times negative 1 would be positive 7i. Don't forget that I on there. Plus 2i minus 4 minus the square root of 3i. All right. Sorry if you hear pages flipping. I'm trying to find the answer key to this. All right. All right, so now we are going to put our real part together and then our imaginary part. So our real part is going to be this negative 2 right here. That has an imaginary, that has an imaginary, this negative 4. Okay, negative 2, negative 4 would be negative 6. Plus, then our imaginary part, which is going to be 7i and 2i, which will be 9. So we're going to say 9 minus the square root of 3 times I. You could say 9 if you put, oops, I got too many 9s there. Let's see. Yeah, like that is what it's supposed to look like. Now, if you put your answer as negative 6 plus 9i minus square root of 3i, I would still count that right. That's okay too. That just means we're distributing that I onto the 9 and to the square root of 3. All right. B. All right, so this one's got I to the third. That means we've got 1, 2, and 1 left over. This one is 5, and that's got 2 of them. This one is 5i. That one's a 7. 2i to the 5th. That means we'd have 1, 2, and another 1, 2, and another 1. All right, so right here that's going to make negative 1. So 3 times negative 1i plus this will make negative 1. So 5 times negative 1 plus 5i plus 7 plus this is negative 1 and that's negative 1. So 2 times negative 1 times negative 1i. All right, then we're going to simplify down further than that. 3 times negative 1 would be negative 3i. 5 times negative 1 would be, oops, I need to get rid of that plus sign because that needs to be a minus. Minus 5. Here we've got plus 5i plus 7 plus, oh, we don't know if it's plus or minus yet. We're going to do negative 1 times negative 1 would be positive 1. Positive 1 times 2 is just 2, so plus 2. And then we've got an I left right there. All right, now first we need to do our real part and then our imaginary part. So here's real is negative 5 and positive 7. 7 minus 5 is 2. Okay, and now our imaginary parts, we've got negative 3, positive 5, and positive 2. So 5 plus 2 will be 7, minus 3 is 4, so plus 4i. And there's the answer to that one. All right, it seems like a confusing concept, but it's not really that hard. If you have any questions, you can just save those problems for class, or you can message me. All right, thanks. Bye.